Hi everyone, I'm Yitong. I'm very excited to share with you our research ABC towards the universal code styler through model merging with you all. Before I start, I just want to mention that I caught a cold yesterday, so I might cough during my speech. Code style refers to not only formatting, but also to overall structure and organization of code. Both academia and industry recognize its importance. Many companies and open source projects has created their own guidelines. And it has been a long-standing aspiration to build a model capable of transforming code between any given style. Here's an example. You can see that style guidelines are typically formed through a combination of both unique and shared criteria. And different guidelines can lead to varied implementation of same functionality. However, due to shared criteria, these implementations also have similarities, which is highlighted in the figure with same colors. So given this compositional nature of style guidelines, many code language model-based style transformation methods use prompt engineering or supervised fine-tuning. For example, prompt with exemplars, prompt with natural language, and multitask training to enhance models' ability to transform code according to these individual style criteria. So these methods results in models capable of basic style transformation, that is, to transforming code according to a single style criteria at one time. However, this approach often exhibits weak performance in combination style transformation, that is, multiple style criteria in one time. Moreover, their ability to transform code tend to degrade as the number of criteria increases. Also, there is a shortage of high-quality, publicly available dataset to support this task, and there is no task-specific evaluation metric tailored to this task. So to overcome this key limitation, we first propose a new framework called Absent Basis Combination, short for ABC. In addition, we create and publicly release a new dataset called Basis and Combination Code Style, abbreviated as BCCStyle. Finally, we introduce an evaluation metric called CS4 BLEU, which stands for Code Sequence, Syntax, Semantic and Stylistic BLEU. First of all, we introduce the ABC framework. Here's an overview. At a high level, ABC comprises two main phases. Phase 1, supervised fine-tuning basis style. So it first uses supervised fine-tuning to learn basis code style. So for each code style criteria, ABC fine-tunes pre-trained code language model on corresponding basis style dataset. And this results in basis style model, which is they specialized in transforming code to a specific basis style. So in phase 2, camp merging combination style. In this phase, ABC merged the basis style model from phase 1 to develop model capable of handling combination style transformation. So for camp merging, it's a specialized model merging method, which stands for clip and amplify merge. We designed for our task. So it has 4 steps. Step 1, clip. For each basis style vector, we clip the basis style vector based on a ratio C%. And step 2, amplify. We apply element-wise amplification with a scaling factor A, and then step 3, we merge the task, we merge the style vector. For each parameter, we compute the mean of all non-zero values. And finally, the merged style vector are applied to the pre-training weight to obtain the final merged model. So we also briefly introduced the theoretical insight of model merging for style combination. So we are inspired by Ehorko's task analogy theory. So let tau A be the absent style vector, and tau Bi and tau Bj be two different basis style vector. We can construct the true style combination vector tau Cij equal merge tau Bi plus tau Bj minus tau A. And this is because the four style A, Bi, Bj, and Cij satisfy the analogous relationship of style vector Cij equal Bi plus Bj minus A. And since our method do not need to relearn the absent style vector that pre-trained language model has already acquired, so the tau AI is a zero vector, and the two styles combination vector formula is updated to tau Cij equal merge tau Bi plus tau Bj. So up next, we create and publicly release a new dataset called BCCStyle. So this dataset includes the two main style representation methods used in currently language model-based approaches, along with 7 style criteria extracted from widely adopted code style guidelines and all their possible combinations. Here's an overall statistical summary. So next, we introduce the evaluation metric CS4 BLEU, abbreviation for code sequence syntax, semantic, and stylistic BLEU. This evaluation metric is for the quantitative assessment of code style transformation task, and this metric measures code similarity from 4 perspectives: BLEU data flow matching, code structure, and library calls. So finally, we conduct experiments on proposed evaluation metric and framework. So we conduct our experiment on one NVIDIA GeForce RTX A6000 with 48 gigabytes GPU memory. We conduct experiments on 4 pre-trained language model from 2 families of code language model. They are Chen coder and DeepSeek coder. So we choose these 2 language model family because they represent the best performing open source model for code generation task. And because of memory constraint, we choose only the smallest 4 variants of this model for our experiments. That is Chen 1.5b, DeepSeek 1.3b, Chen 1.5b, and 3b. So we first look into CS4 BLEU's accuracy, consistency, and human correlation compared to existing metric. So we compare 2 existing metrics, including BLEU, RAG, Code BLEU, Crystal BLEU, and CS-SIMS. So the results here indicates that CS4 BLEU achieves the highest accuracy among all evaluated metric. And you can see that the code-specific evaluation metric, which is the green part in the table, consistently and significantly outperform natural language evaluation metrics in terms of accuracy. Next, we evaluate the consistency of the metric by measuring the variance in the change of metric score. So a smaller variance here in the metric score change indicates greater consistency. The results in the table shows that our evaluation metric outperform our other metric in terms of almost always outperform our other metric. So especially in evaluation metrics with higher accuracy, which is the green part of this table, our metric our metrics consistency always exists other metrics. And to investigate the correlation between CS4 BLEU and human evaluation, we also designed a questionnaire. And we designed a questionnaire and collected the response. So we compute the Pearson correlation efficient between each metric. So the results shows that our metric achieve highest correlation with human evaluation. So second, we present the average evaluation result. We can see that ABC can improve style transformation performance and also alleviating performance degradation from basic style to combination style. So we further investigate this ability. So as the number of style criteria increase, the experimental results shows that our criteria can effectively alleviate this performance degradation. So finally, we compare the performance of our merging method with existing mainstream model merging methods. So here's the results. It shows that our model merging methods also outperform existing mainstream model merging methods. So that's all for my presentation.
Okay, thank you for the talk. Is there any question from the audience? Yes, please. Very quick question, please.
Thank you for your talk. You have reported human correlation coefficient. Yeah, could you please elaborate a bit? How did you gather human preferences?
So we designed a questionnaire to ask participants to determine two code which is better match the coding style of a given reference, and then we compute the two code to the reference code code style similarity score, and then compute the Pearson correlation score. So.
Thank you.